Hi there. Thanks for clicking on this video and giving me your time today. And I hope that you're getting ready to write some notes in your math notebook. Let's keep in mind something. I'm recording from home, and that means we have less than ideal conditions. So you might hear some background noise from time to time and realize even my graphics here, when I print out my lessons, they don't tend to print very well. So I'm doing my best. All right, we are about at the end of Unit 4, Section 1. It's hard to describe, but Unit 4 is broken into two separate chunks, and this is really just the first chunk of Unit 1. But for now, we're just going to say we're wrapping up the first chunk of Unit 1 or Unit 4, and this is called Lesson Number 9, Scatter Plots in Lines of Best Fit. Certainly not difficult at all. The way the lesson was originally designed, I usually teach this entirely differently. However, given the circumstances that we're remote learning and we're not in class together, I sort of modified this lesson to make it somewhat easier for you to do without my direct support in the classroom. So you're going to see as I start scrolling through these next few pages of notes, a lot of things that I've crossed out and kind of scribbled over. You'll see I've kind of handwritten my own questions. So again, realize this is all done to your benefit and bear with me. I'm doing the best I can. Okay, here we go. Scatter plots and lines of best fit. Let me see if I can zoom in a little bit closer on that. Oh, sure. There we go. That's a little bit better. I know it's small and probably difficult to see, but I'll talk you through it. Scatter plots and lines of best fit. First definition is a scatter plot is a graph that is used to investigate the relationship between two variables or two sets of data. So what you do is you have these two sets of data, and then you put one as the x-axis and one set of data as the y-axis, and then you plot the points as the data goes together. You'll see here in just a minute when I start talking about these scenarios how scatter plots work. And then once you get all of these points plotted, you don't connect them, you don't draw a line. Well, you are going to draw a line, but not like by connecting the dots. That wouldn't really work. What you look for overall is a pattern in the dots. And when you find the pattern, or if you determine there really is no pattern to the dots, we talk about there being a correlation. So the next definition is about the word correlation. And the definition says, correlation or trend, which means kind of like a pattern, means how the points in the scatter plot are related to each other. And there are three trends or three correlations that we notice when we create scatter plots for two sets of data to be compared to one another. First example is, let's say you are making a scatter plot, and for every student in your class, you asked them two questions. How much time did you spend studying for the test? So this down here, the x-axis would represent, you could do minutes of study time. Let's say this is minutes or hours or whatever, or days, I don't care, whatever you want it to be, however you measured your time. And then you also asked each student, what percent did you get on the quiz? So then the percent or the second data set becomes your y-axis values, okay? Now I know these numbers are super duper blurry, and you know what? I'm here in person and I can hardly read them, which means I'm sure you on your little tiny Chromebook probably can't read them at all. I'm not gonna really focus too much on the numbers, so much as we're looking at the pattern. So each of these dots represents one student. So for example, this student right here studied very little. Maybe he studied for 5 minutes. and he scored a very low percent. Maybe he scored a 20%. I don't know. I'm kind of making up these numbers as I go. And then if I were to pick a student like this student way up here, and I were to come down, look at this student would have studied quite a bit of minutes. Maybe this student studied for 45 minutes. And how did they do with their percent? Well, you come across here, and they scored a much higher percent. I'm guessing this is like a 90 or a 95% on their quiz. So then what the data tells us is that the more time students spend studying, the higher their percents tend to be. And when you notice that your dots have a pattern or a correlation that's kind of sprinkled in the upward direction, just like if this were a positive slope, that's called a positive correlation. I don't have room to write the whole word, but that's a positive correlation. The more time you spend studying, for the most part, the higher your percent is going to be. Now, we should talk about things called outliers. This is an outlier. See that kid? How much time did he spend studying? I don't know, maybe 35 minutes or something like that. And how did he score? Really, really high. So that's an outlier. That's a kid or a data point that doesn't necessarily fit in with everybody else, but it exists. And that happens in real life. Sometimes I'll have students who don't need to study at all, and they can score high percents. And on the other hand, occasionally, you will have a student that really studies and studies and tries and tries and tries and tries and tries. They spend a lot of time, but they don't score very well. So you could have an outlier like this as well, okay? So realize that outliers exist, and when we look at correlations, we tend to ignore the outliers. We just look at the main trend of the overall data or the data points. Okay, now let's look at the next scenario I came up with. Let's talk about the weight of a vehicle. So these are vehicles that don't weigh very much. These are vehicles that weigh a whole bunch. So maybe this is like a bicycle or a smart car or a moped or a motorcycle. And then this would be like a huge vehicle, like a semi or a humongous boat or a ship or a yacht or maybe even an airplane. I don't know. So, you have to imagine that these are very lightweight vehicles and these are very heavyweight vehicles. Now we're going to compare the weight of the vehicle to how many miles per gallon does it get for gasoline or for its fuel. And so I start doing surveys, and obviously a bicycle wouldn't use fuel, but anything that consumes fuel, I would start gathering data. Okay, this vehicle weighed very few pounds. Maybe it weighs only 500 pounds, and it gets phenomenal miles per gallon. Maybe it can go 75 miles for every gallon of gas that it can hold, right? That's very fuel efficient because it's a lightweight vehicle. And then sure enough, I go on and I survey bigger vehicles, and now I'm talking about cars, and now I'm up here, I'm getting towards like trucks and big SUVs, and then I'm working, and now I'm on to like semis, and then I get up here to things really big like heavy ships. And what I find for these dots or these different vehicles is that the bigger they get, the less they get for their miles per gallon. So for example, a humongous ship would get very few miles per gallon. In fact, sometimes it might even be like only gallons per mile. They might get less than one. It could actually be like less than one miles per gallon. I mean, it's so tiny. They use a lot of fuel to go even 1 mile. So what we see then after we plot all these points is that sure enough, as a vehicle gets heavier, it becomes less fuel efficient, meaning it gets fewer miles per gallon. So what we notice is that the dots sort of have a downward trend or a downward pointing slope. That's called negative, just like negative slope. Negative correlation. Okay? And then yet a third possibility for your scatter plot is you survey every student again in your class, and you ask them 2 questions. Question 1, what is your shoe size? Okay, and you write that down for every kid. And you go back to those kids and you say, now, how many pets do you have? And you write that number down for every kid. Okay, so every point here represents one student. This student has very small feet and very few pets. Maybe they're a size 4 and they have maybe 2 pets. Okay, this kid, look at this kid, very small feet, size 4, but lots of pets, 8 pets. Okay, and then these are all kids. Look at, what's this kid? This one right here. Big feet, right? Maybe this kid's like a size 10, but only 2 pets, or actually that's 1 pet. But this kid, let's say this kid up here, he's a size, maybe he's a size 12, I don't know, and has 8 pets, size 12, 6 pets, size 12, 5 pets. So then look at these dots. They're everywhere, aren't they? You can't draw a line that represents these, so this is called no correlation. Because guess what? There is no relationship between how big your shoes are, or how big your feet are, and how many pets you can have in your life. So that's what scatter plots do. They help you visualize relationships between 2 sets of data, or 2 variables. Okay? Now, as I said earlier, the way I originally or usually teach this lesson is not how I'm going to teach it today or this year, due to the obvious COVID circumstances. So we are going to talk about something that's called a line of best fit. If you look at a scatter plot and you notice that there is in fact a pattern to the dots, so this has a negative correlation, the dots are sprinkling down to the right, you can take a straight edge and try to draw a line right through the center of the data that would represent the data overall. It's called a line of best fit. Now, it's not perfect. No, it's not perfect. But you can kind of use that line of best fit as an estimate to represent the rest of what's happening with all those other data points. So when you draw a line of best fit, you typically try to get it to pass through 2 points. And if you really cannot make it pass through 2 of your points, which they did here, I think they got that point and this point. If you can't get it to go through 2 of your points, right dead center, then you need to make it go through 2 of the corners on your graph paper. That way you could calculate the slope, and then hopefully you could even calculate, if you extended your line far enough, you could calculate your y-intercept over here. This is the y-axis, and this is the x-axis. Okay, so a line of best fit, it just helps you kind of speak about the general pattern of your data. Now, if we were in class, we would actually be calculating the slope, and we'd be calculating the y-intercept. And we would be writing equations to represent our data. We're not going to do that. What we are going to do, though, is we're going to look at the data, and I'm going to ask you some questions. I'm going to ask you to make an estimation or a prediction based on the data that you see here. So here's what I'm talking about. Our first prediction says, when X is 45, so I guess it's 45 years old in this example. So when X is 45, that's right here. Would it make more sense that Y would have a value of 40, and this appears to be heart rates, or for Y to have a value of 55? Well, once you get that line of best fit drawn or visualized, even if you just visualize it, it's asking, would it make more sense for Y to be 40 or 55? So we go over here to where 45 is, and I kind of just imagine or focus on that line right there, okay? Now the question is, on this line, would it make more sense for the Y value to be 40, which would be right here, that would be this point, or would it make more sense for Y to be 55? Y is 55 right here, which would be this point. Which of those possibilities is closest to your line of best fit? It's this one. This prediction is more accurate because it's closer to your line of best fit or your trend line. It's also called trend line. So if I refer to it as a trend line, same thing. All right, this is super simple, right? I hope so. We do have some more here. I know I told you this was going to be sloppy. Here we go. Number 1. Determine which equation best. No, we're not. These directions are terrible. Blue. We're not doing that. Here's my data. They've drawn a line of best fit or a trend line, and it's asking us when x is 8. Here's x. Here's 8. I know it's difficult for you to see, but I'll draw a line where x is 8. Would it make more sense for y to be -6, which is right here? So if we came across, that would put a dot there. Or for y to have a value of -1. -1 is here, but we're talking about over here where x is 8. So once you get those two possibilities visualized, which one seems to closest hit or match the trend of the dots or your scatter plot or your trend line or your line of best fit? It's clearly this one, this dot, which was our first choice, where y was -6. Okay? Let's do a few more. Here we go. This has a positive correlation. We have a line of best fit. They're asking us if x is 7, let me draw that line for you. This is where x is 7. Would it make more sense for y to be 2? 1, 2, which would be here. Or for y to be 12. Y would be 12, be off my chart. Y would be 12 about here, which would be up there. Oh, right into my directions. Which of those dots appears to be closest to our line of best fit? Definitely off the chart, y of 12. This guy, if he landed out here, he'd be an outlier. He wouldn't even be close. We need a dot that's closest to our line. Okay, 2 more. Here we are. There's that nice line. We're saying now, imagine that x is 6. Again, these graphs are so tiny and terrible. 1, 2, 3, 4, 5, 6. That is off my chart, round about here. Would y be 1 or would y be 5? Well, y is 1 here, so you'd come across and it would intersect there. And y of 5, 1, 2, 3, 4, 5, way up here at the top, you'd come across and put a dot there. Which of these dots is closest to your line of best fit? The very first one where y was 1. I don't think this is that bad. Let's just do one more. X is -5. That's our starting point. Way out here, that's -5. How about it? Y of 4, which would be there, or y of 2, which would be there. Well, neither one is great, but definitely I think this one is closest, so y of 4 is most accurate. All right, so scatter plots and lines of best fit and positive and negative correlation, it's really just a visualization of the relationship between two variables or two data sets, all right? So you'll be doing an IXL to go along with this, and I don't expect that you'll have much trouble. Thanks for watching. Bye-bye.